Well, if we can write the name, we can also use the name to write the chemical formula. So we can look at this backwards. So let's start with sodium nitride. Now right away, sodium nitride, sodium is Na with a 1 plus. Nitride is a nonmetal. Nitrogen, nitrogen on the periodic table is N with a 3 minus. And now we do as we did before, get some more sodium. So the charges are balanced. We have 3 plus in the sodium, 3 minus in the nitrogen, and our formula then is Na3N, sodium nitride. One last one. What if we have the formula and we want to find the charge on the ion? Very, very typical situation, such as SnO2. Now SnO2, we want to now write this as the name. We need to find the charge. Notice Sn has two different charges. It's either a 4 plus or a 2 plus, but oxygen only has a 2 minus. So we're going to use that information because we know we're working with tin with some charge. We don't know what that is, but oxygen is guaranteed to be a 2 minus. Now this subscript is actually going to help us a lot. That tells us that we have 2 oxygen. Now if that's the case, there's 2 oxygen, now we know that the negative charges add up to -4. Now that gives us a big clue because we now know that this charge must also be a +4. Now because there is only one Sn, that tells us right away that these charges are balanced and the charge on Sn on the tin must be tin 4. Tin 4 oxide would then be the name of this chemical formula. Let's look at another type of ionic compound called a polyatomic ion. And what a polyatomic ion is certain atoms form a bond, and then those bonded atoms actually have a charge and act like a single ion. So these polyatomic ions, and there are many of them, can be found in your data booklet on page 5 of your data booklet. And we're going to use this page 5 along with our periodic table to write the ionic compounds for some polyatomic ions. So let's look at the first one here, and let's look at sodium carbonate. Now, the big thing to notice, if we have an 8 or an ite or an ic, then it's going to be a polyatomic ion. So we can't find carbonate on the periodic table, but we can find sodium on the periodic table. So we'd look to page 5, our list of polyatomic ions, and you will find carbonate on that list. So we're going to combine sodium and carbonate. Sodium has the symbol Na with a charge of 1 plus, and carbonate has that symbol now of CO3, and it has a charge of 2 minus. Now once we have this, it's no different than what we've been doing before. We need to balance the charges. So we need more sodium, and now if we look at our balanced charges, we have 2 plus and 2 minus. We can combine them together, and we have 2 NAs with 1 CO3, and we have Na2CO3, just the same as we've been doing before. What about tin 4 phosphate? Tin 4 phosphate. Well, periodic table, we find tin. Remember, tin is multivalent. It has 2 potential charges, a +4 and a +2, but we have that 4 there. We know it's the +4. Phosphate, we have to be careful. Phosphate, we're looking for that ATE, not phosphite. So we're going to use the proper symbol, PO4, with a 3 minus, And so tin 4 is SN4 plus. Phosphate is PO4 with a 3 minus. Now this one, the numbers get a little bit higher, but to balance the charges, we'll need 3 of the tin 4s. Notice the charges here all balance to a plus 12. All of these 3 minuses, if we add them up, are negative 12, and we have balanced charges. Now with this polyatomic ion, the difference is we need to put some brackets, and those brackets are very, very important. We count the number of tins. We have 1, 2, 3 tins. That's where the 3 comes from. And 1, 2, 3, 4 PO4s. That's where this 4 comes from. So let's try one last one. Let's try potassium acetate. Potassium acetate. Again, potassium, periodic table. Potassium, there it is right there. Charge of plus or 1 plus. Acetate. Turn to your list of polyatomics. It's the one right at the top. It's the one that has a lot of atoms together, but we don't care how many atoms. We write it out the same way. Potassium is a 1 plus. Acetate is CH3COO with a charge of 1 minus. And we get really happy because look at these charges. They are already balanced. So all we need to do is write this together. KCH3COO. And that's the chemical formula for potassium acetate.